Right, so we have a current radio session, and we have gone through multiple concepts about AI Gateway, MCPs, etc. And I want to introduce here LangDB, which is a product we have been working on, which is fundamentally what we call it an AI runtime that supports multiple functionalities as an AI gateway and MCP servers as well. And it's entirely written in Rust. I'm going to go through the details of it and then, all right. Quick intro about myself and my co-founder. I'm Matteo. I'm the co-founder of LangDB. We started the company about a couple of years ago with a different product in reality, and that's the where the name comes from, LangDB actually. We pivoted towards more towards the AI gateway proposition in the last few months. We are backed by Sequoia and Gradient from Google. Right, so I'm going to talk a little bit about our experience developing agents and how we ended up with our concept of AI runtime. The challenges that we face when we develop these multi-agent flows, and that we just briefly discussed about how to interact between multiple agents and between multiple tools, and especially how you understand and debug the traffic among them. Then I'm going to go through a quick demo of LangDB and show you how you can basically easily build what we call a virtual model, which is an AI runtime, and how you can later on use it. All right, so we have talked about AI agents, and we have talked about how what are all the functionalities required by it. So we said that an AI agent is by nature non-deterministic. So you have a bunch of prompts that defines the behavior. You might have multiple LLMs as well. Actually, it's not just one LLM, because in some and for different reasons. In some situation, you find out that for some task, one LLM is better than the other, and in another situation, you might find out that because that task is very simple, you don't require a 70B model, but a 5B model is good enough for what you're doing, actually. So you want to save costs. So you want to have support for multiple LLMs. You want to have support for multiple tools, MCPs in this case. And then you want to be able to enforce some guardrails. And on top of that, you want to be able to understand what's going on between all your agents. So imagine if you have a system like what was just described, where you have multiple LLMs interacting with each other and multiple MCPs. How do you understand who is calling what are the payloads, and how do you debug if something goes wrong? So, and this all came through thanks to a multiple iteration while we developed some agents. But one of the agents that we developed for ourselves to promote our product was basically a kind of like a DevRel agent that does a bunch of things actually, and brought us some inbound leads as well actually. And these agents, basically what it does some community monitoring. So it goes and monitor Reddit, Hacker News, Slack, and Discord channels. It checks out for conversations based on some topic. In our case is multi-LLM access, the MCPs, etc., etc. When it finds out something that is potentially relevant because of starting with keywords, he basically analyzes the context, does some context research, and then it does some relevance assessment. So understand, okay, I found something that is relevant to multi-model access. Is it relevant to post something here to promote our product? Yes or no? And then based on that, take a decision and write a post and say, check out, LangDB could be helpful to use. So we developed this agent for basically ourselves, and it's the behavior here is pretty complex actually, because you go do a search, you analyze the content, you need to summarize this content and put it into the context to understand if the post is relevant, and then take a decision if it's relevant, generate a new content and start post it. So we started to realize that we needed a bunch of things, and these are mostly the challenges that I briefly mentioned before. There is this multi-agent complexity. So you have multiple agents talking to each other. You can call it agent, you can call it, it's our concept, in our terminology, we call it virtual model, because this is not really an agent with a complex behavior, but it's basically a really specialized agent doing a simple thing. Like, for example, imagine a agent that does summarization taken from multiple content. Actually, it's kind of like what it was described before in the sample before. It's more than an MCP server because there is an LLM component, but it's not a fully a full agent, meaning that it does have the full path of execution. It basically centralizes some execution path. The integration challenges, to be honest, when we developed this, MCP was not around actually yet, but then we started realizing that tools integration is painful and tricky actually. MCP makes it much easier, and but we said it's a good at that time. Obviously, we're already working on LangDB, and our primary product was the AI Gateway, and we saw a huge potential in embedding the MCP support in the AI Gateway itself. So the tools resolution and security enforcement, and then I will go through a little bit more about it, is fully handled at the AI Gateway. Dynamic routing is another important aspect here. As I mentioned, you want to be able to route to different models for different purposes, actually. You might want to route, for example, from a simple round robin because you want to evaluate. Like, for example, we had a customer that deployed a solution, and DeepSeek came out, and they obviously wanted to test their agent with DeepSeek instead of OpenAI. So obviously they didn't want to completely migrate the entire solution. So they said, okay, let's route 5% of the traffic to DeepSeek and analyze how the system is performing. You have other type of routing, which is semantic routing, like trying to route you to the best model at the lowest cost based on the prompt. In this case, for example, we have a model that is trained on the LLM arena that automatically routes your request to the appropriate model based on the prompt, and different other routing. But the whole idea is that you need to be able to route to multiple models based on the prompt. This goes hand by hand with the model selection. How do you select your model? And this is important to have a good playground to do this. And quality and cost and process engineering. Let me move on because otherwise, all right. So the whole idea is to have this AI gateway concept that was introduced. It's not a completely new concept. It's something similar that we were talking about before, that gives you all these possibilities, gives you logging and traceability, so be able to trace, understand what's going on, and all the requests are logged. Routing, cost management, so that being able to control how much is the cost at each particular request. Giving you the ability to perform evaluation, as I mentioned. Let's say I want to evaluate a new model. I want to evaluate the quality and the cost and decide how to move forward. Guardrails and policy management. I need to be able to enforce what the user can do or cannot do. And the last but not least, the MCP integration, allowing to perform automatic resolution of MCP. So we came up with this, in addition to in the AI gateway itself, we came up with this concept of virtual model that is kind of like, I would say, an agent, but less than an agent. So the whole idea is that you can take a model, let's say ChatGPT 4o, whatever you want, and then you say, okay, I'm gonna preset with some system prompt, I'm gonna attach some MCP, I'm gonna attach some guardrails, and that's my component that I want to use in my more complex agent execution flow. And this model actually gets exposed as a normal model using completion API. And you can basically use this preset model in any of the framework, like GUI, whatever you want, because it's purely open and open. So having said that, I want to run a little bit through the product itself and show you how this virtual model concept works. And I'm gonna do a live demo. Hope everything will go all right. To create a virtual model from scratch here. So this is our dashboard. We have a bunch of projects. Let's create a new project here. Let's call it MCP Demo 2. Okay. And for each project, I can actually set the cost limit that I want to use. So I can set a overall limit, a daily limit, a monthly limit, actually. So once I create my my MCP Demo 2 that I have here, all right. Okay, this network, all right. So here we have a playground with multiple models. And here is where I'm basically configuring my virtual MCP server. So let's say we choose ChatGPT 4o, and now we're going to give a name to this virtual model. And as you can see here, I have the model parameters that we're not going to touch, and we have a bunch of tools and we have a bunch of guards. Tools are basically MCP server. Okay, let's go to first configure our tools. Let's say we want to create a simple trip planner, actually. In this case, and this actually brings up the security aspect of MCP. You know, when you start using a lot of MCP servers, you are going to have multiple servers with multiple functions available. So you want to be able to restrict which MCP server and which functions are available to your user. In this case, let's say, for example, that I want to use a search functionality. and I say I'm gonna add the DuckDuckGo MCP, and then I want to use, let's say, a Gmail, okay? I want to use Gmail to when you can see here that my Gmail MCP server has a bunch of functions. And here I can say, okay, I want to create a virtual MCP server with only some functions that I want to use, and only those will be exposed. Okay, let's give it a name, trip planning MCP. All right. Create virtual MCP server, and I created my virtual MCP server that is available here. Now I go back to my playground, and I have my ChatGPT 4o here, and let's create a trip planner model, okay? And here I'm going to say, okay, I'm going to select the trip planning MCP, which where I will get access to all my MCP servers that I pre-selected. And I'm going to set a system prompt here, where I'm going to tell I had the message here. So let me go and get my message. Where is it? All right. Okay, I have my system prompt here. You say you're a planning assistant. This is what you have to do, and I can use this in the as a system message. Okay. All right. I'm gonna save my virtual model. Okay. Now I created a virtual model which has access to MCP and as a system prompt associated to it. And I say, help me plan a trip to a 3-day trip to Singapore. Okay. Now because my system prompt says use this tool, MCP is available, then it is start invoking the MCP tool and start planning my trip. Now, the interesting thing, and this is what I was mentioning about before, the inspectability, you can see that I have my response here, but here I have a complete view of what is happening behind the scenes, okay? So you can see here that this is my request. I have ChatGPT 4o invoked. There is a tool call, which is the MCP, and that the tool call basically is invoking the search functionality and search MCP server. And through this, I can go and see exactly what is the payload. I can see whatever is happening. Now, the advantage, I'm doing this from my dashboard here, just as a test, actually. But because this is a virtual model, I can take this virtual model, access through it using my OpenAI API, and when I get back to my dashboard, I basically have everything recorded. So all the actions, all the logs are going to be all visible here and inspectable. Now, just one last thing I want to show you. Let's say here that I say, give me the recipe for tiramisu. Okay, and because I didn't set any guardrail, this will basically go and do some search and give me the recipe. So I don't want that. I can do the same thing with MCP with guardrails. For example, I go to guardrails and say I'm going to create a new guardrails. I'm gonna choose the topic adherence guardrail, and say topic adherence trait. I'm going to say block validate my input, and then I'm going to say here that I want to allow only topic that are planning a trip. Okay, and that's about it. All right. So now I created a new guardrail that uses another LLM as a judge to validate my request. Now I can go back to my playground and I can edit my virtual model and say, in addition to the tools, add a guardrail that I just created. Once I added that, I can, let's go back and ask, give me the site for lasagna. And obviously, in this case, it will tell me adherence trait is not passed. Actually, my guardrail kicked in. And if I go and look at the logs, at all my traces, you will see here, and now the trace takes a little bit to show up. Right. And you can see here that my guardrail kill has failed because of my guardrail that I attach. So this is the whole idea. Create a virtual model where you attach multiple MCP tools, the functions that you want, the guardrails, routing, and whatever you need for your core functionality to work, and then be able to access it. Another thing that I forgot to mention, we support some MCP server, and we will allow users to deploy their own MCP server. And we support both key-based and OAuth to MCP server. So basically, when you have an OAuth to MCP server, I didn't show it to you. For example, if I was saying, I can do it actually. Let me see. For example, let's say here, I'm going to say, oh, but I didn't put in the guardrail actually. Now it won't let me do it. Well, let me do it one thing. Remove this, or never mind. So basically, when I have a OAuth based MCP, in the case of Gmail, MCP in this case asks me authenticate yourself using OAuth, and the key to access your Gmail is that we take care of all the storing the key and the entire flow. So this would simplify also how you integrate MCP with third-party products. So yeah, that's pretty much how the product works. What we solve, and that's it. Thank you very much.
We deployed on-prem. Yes. So it tracked. And how about the guardrail?
Everything. So the LangDB is basically a AI gateway that gives you all this functionality as a gateway. So the moment you switch your URL from OpenAI to LangDB, because it's OpenAI compatible, and we give access to 250 plus more. So here we have two possibilities. One is like use our credits or use your own key. You put your own key, we do key management, and once you replace URL, you get all the functionalities. You can use plain models, or you can go here, create your virtual models, and expose those virtual models to your agent application, and all the enforcement, cost control, guardrailing are in there, and you have the full tracing and logging for it.
I think I also asked about the guardrail.
Yeah.
So is it like a safety measure to the agent?
Yeah.
And I use your stuff to build the agent.
No, we don't want to be an agent framework. No? So you still keep using your agent framework that you want. We want to give the ability to give you the core, constitute the core components. And one of the core components is the security one. So whenever there is a LLM interaction, how do I make sure that the content of my request or my response is correct?
Yes. So I think it's like when they use the agent lock. So like the user, they need to put the question and to build the prompt. So it's really, the user really expect to get the correct info.
Well, it depends. We have different type of guardrails. Okay, so one guardrail we have deterministic guardrails, which are basically I want to validate that the response does not contain these keywords exactly, for example, or I want to ensure that the response is only going to be a JSON structure output. That's a deterministic one. But then we have the non-deterministic one. It's basically where you can fundamentally you can build another virtual model to evaluate the request or the response of the data coming in. So I can create a virtual model that says just simply evaluate the response based on some criteria. But this virtual model, for example, could actually use an MCP to validate some request response. So it's highly composable the way you construct the guardrails.
Okay, so the UI is like it's really depends on the developer's needs. So what kind of agent they want to develop, and then is what protection the developer expects.
That's right.
The guardrail can just provide this kind of work.
Yeah, that's right. But even for not just the guardrails, but for example, let's say that you are building a functionality, okay? So you can say, I create a virtual model. This virtual model, I set the system prompt like I did. I set the guardrails, I set the MCP server, and then this whole virtual model provides the core functionality. Then I expose to my developers to integrate in other agents, like a unit of work.
Okay. Yeah. Thank you.
Sure.
So, any questions? So if we don't have questions, then thank you for coming, Matt. And again, it's giving away the t-shirts. It's medium size. If you want one, just go outside the table and grab one. And thank you again. Bye bye.